There are times when prepopulating an array with values can be useful. We already saw in earlier videos how to do that using array literals. This array is prepopulated with the four numbers 1, 2, 3, and 4. This approach of writing out all the values, which is known as an array literal, is only practical when there is a small quantity of elements and the exact values and quantity of them is known in advance. To prepopulate very large arrays or arrays that will have a user-determined size, we need some other technique. The array constructor, when passed a number as an argument, creates an array with the specified size, but it doesn't put any values into the elements. This code creates an array of 5 elements, but all elements are empty. If I attempt to access the value of any element, I get undefined, but that does not mean the element holds the value of undefined. If I set the first element to actually hold the value of undefined, a console log of the array shows that undefined value separately from the empty ones. Because using the array constructor in this way creates an entirely empty array, it is not possible to directly use the map method on the array that is produced to create an array pre-filled with values. You might expect this code to create an array of 5 elements in which every element has the value of 42. The map method skips all empty values. Since every element is empty, all of them are skipped. It still produces a new array of the same length as the array being mapped, but all the values are also empty. Note that skipping over empty values is not unique to map. This also happens with for each, reduce, and reduce right. This example shows using for each on an array that has an empty element. Deletion caused the element with index 0 to become empty. Note that the first console log outputs index 1 with a value of 2. The first item in the array is skipped because the deletion makes it an empty element. If I substitute the deletion with code that assigns a value of undefined, we get a console log for the first element showing that its value is undefined. If you want to use the map method on the array produced by the array constructor, an additional step is needed to fill the array with something. The array fill method fills the entire array with the specified value. This code creates an array of 5 elements, and the fill method sets the value of every element to 42. It is possible to chain together the creation and filling of the array, and this is common. For readability, this can also be split into 2 lines while still being one statement. The traditional place for the split is right before the dot. In addition to being a bit easier to read, it also gives a convenient location for adding comments relevant to a specific part of the statement. The fill method is also useful for making the elements not empty, which is necessary if you intend to use map to do something like creating a sequence of different numbers. Before we make a sequence using map, let's look at how map could be used in combination with fill to produce identical values. This code failed before because map skips empty values. The fill gives non-empty values, so they are not skipped. Note that it's possible to use fill without any parameters. This code still produces the same result if the 0 parameter is removed. What happens is the fill without any parameter sets every value to undefined. Map only skips empty elements. It doesn't skip elements that hold a value of undefined. Here is an example of using map with fill to generate a sequence. The array constructor is used to create an array of 5 empty elements. These elements are filled with 0 to make them non-empty. Map is then run on the resulting array of 5 zeros. The callback of the map takes 2 parameters. The first is the value and the second is the index. This code adds 1 to the index and returns it. The result is the sequence of 1, 2, 3, 4, 5. The length of this series can be easily adjusted just by changing the 5 to a different number, or a variable could be used instead of a hard-coded numeric literal. Using the fill method with objects is allowed, but the result might not be what you want. This code creates an array of 5 elements and fills every element with the same object. If we run this code and look at the output, there is nothing surprising. However, changing any of these elements will change all of them. The fill method uses the same value for each element. Because these values are objects, they are all the same object. They aren't copies of the object, they are the exact same object. So changing one will change all of them. This creates a problem if you want to use fill to create a 2-dimensional array because arrays are objects. This code creates a two-dimensional array filled with zeros, but changing any of the inner arrays will change all of them. This code explicitly sets the value only of the first element of the first subarray, but the first element of every subarray becomes 1. There is an alternative to using the fill method that involves using the from method. Before we look at how to use that as an alternative to fill, let's look at some other uses of this array method. In an earlier video, we briefly looked at using the from method to make an independent copy of an array. We can verify that the copy is truly independent by changing a value in it. The original array remains unchanged. Another use of the from method is to convert a string into an array of characters. It is not the only way to do this, and some array operations can be done on strings without converting them, but we will cover those topics at a later time. The from method can accept a second parameter, which is a mapping function. This enables making a copy and performing a map operation on that copy. This isn't very useful when given a regular array as the first parameter, because using the from method in this way has no advantage over using the map method. Both of the approaches in this code produce the same result, and using map is a bit less verbose. However, it becomes more useful when we don't give an actual array literal. We can instead use a special object containing only a length property. This code creates an array that contains 5 zeros. The mapping function can take a second argument, which is the index. Note that the more common way to write this callback would be to use an underscore for the first parameter. This is a tradition and not a language feature of JavaScript. The underscore indicates an unused value. We only want to access the index and not the actual element, which would have a value of undefined. Using the from method with nesting enables creating multi-dimensional arrays in which all the elements are independent from each other. This creates a two-dimensional array containing 9 zeros. The outer array contains 3 subarrays, and those subarrays each contain 3 zeros. Unlike when using the fill method, these values are independent. We can verify this by changing the value of a single element. Note that none of the other values changed. This approach can also be used for more complex purposes. This code prepopulates a two-dimensional array that represents the initial layout of a game of checkers. The outer if statement checks if row is even and column is odd, or row is odd and column is even. We can see why this is necessary by examining where the checkers are on the board. If we pick any random checker, we can see that it meets the condition of the if statement. For example, the red checker at row 0, column 1 has an even row and an odd column. The black checker at row 5, column 4 has an odd row and an even column. The inner if statement checks the row number. If it's less than 3, then the checkers are red, and if it's greater than 4, they are black. The return of an empty string at the end is for any position that should be empty. Note the use of console.table instead of the usual console.log. This is done both to make the layout easier to recognize as a checkerboard game and also to get automatic numbering of rows and columns. Using console.log works, but it's much harder to decipher the meaning of the output. There is still more to the topic of arrays, but we will be moving on to the next topic. In the next video, we will discuss the topic of loops, which allows code to be repeated. We already saw something similar with array methods like for each and map, but loops can be used to repeat code that is not connected to arrays.